we're just going to learn something that's basically the exact same thing as yesterday, except now we're going to be dealing with particles and volume. So that's where Avogadro's number comes in, and 22.4, okay? So all we're doing today is calculating number of volume or number of particles. I'm sorry, calculating the volume or number of particles produced. So we're doing the same thing as yesterday, except we are going to use different units on either side of that mole-to-mole ratio. So we're still going to have a known. We're going to have we're going to convert that known to moles. We're going to have a mole-to-mole ratio and then another conversion, okay? So you guys already are familiar with 22.4 and you're familiar with Avogadro's number. So let's start with some practice problems. So how many grams of aluminum can react with 336 liters of oxygen? So we have aluminum and oxygen that's going to combine to make aluminum oxide. And then here's our formula equation. So we're going to balance it. We have our known, like just normal problems. It's from the question. And then we have an unknown, which is it's asking us for how many grams of aluminum can react. We always start with our known, okay? We're looking at these, obviously, because that's what we have and what we're dealing with. We are going to write our known first, okay? So instead of it being grams like yesterday, we're given liters. So that just means that whatever is up here will need to go down here. So that's our 22.4 liters for every 1 mole. So that's just conversion. Then we need to do our mole-to-mole ratio because we don't want oxygen, we want aluminum. So cancel those. Okay, so we get these numbers obviously from here like we did yesterday. And then we're going to need to convert because we're not looking for moles of aluminum, right? We're looking for grams of aluminum. So we need to do another conversion. And we will have this we grab from the periodic table. Okay, so for every 1 mole of aluminum, it weighs that much. All right, so those two cancel, and we are left with this number, okay? So in your calculator, all you have to do is take this number divided by this number times divided times, okay? If you didn't do the exponent, it's no big deal. All right, so moving on, we're going to look at same type of equation. We're going to have the multiple step equation. It's not just moles. But now we're going to be dealing with formula units. So anytime you see formula units, particles, moles, atoms, you know that you're going to have to see that dreaded 6.02 times 10 to the 23rd number, which actually isn't dreaded at all. It's kind of familiar to us now, hopefully. So we're using the same equation, okay, so there's that. And we need to produce 137 grams of aluminum, so that's our known. Okay, our unknown is how many formula units of aluminum oxide. Okay, so how many formula units of aluminum oxide? So all we're dealing with is aluminum and aluminum oxide. We're going to ignore this oxygen. So we start with our known right here. Okay, so our known is 137 grams of aluminum. We cannot even get to aluminum oxide until we've converted our grams of aluminum to moles. Okay, so we need to convert grams to moles. Okay, so we just grab this off the periodic table. For every 1 mole of aluminum, it's going to weigh this much. Okay, now the next step, okay, is that mole-to-mole ratio. This is our jump from aluminum to aluminum oxide. Okay, that's how we do it. So we do that. We get these numbers. We take them from here. Okay, then we need to convert from moles because obviously we don't want moles. We want formula units. So we need to convert from moles to formula units, and this is how. Okay, so for every 1 mole of aluminum oxide, we have this many formula units. For every 1 mole of anything, we have this many formula units of that. Okay, that means the moles cancel out, and this will be your answer once you put it in the calculator. Okay, I want to do the very last problem on the homework. It seems to be the most involved problem, so that way we can all do it together. So how many grams of barium chloride are produced when this many molecules of HCl reacts with barium according to the following equation? So word equation is how many grams are produced. So this will be our product when hydrochloric acid and barium react. So barium chloride. So here's our word equation. Formula equation will be HCl plus barium will yield barium chloride. So barium is here, so it's a +2 charge. Chlorine is a -1 charge. So we need to have 2 chlorines for every barium, like that. Okay. So there's our equation. We need to balance it. So we have 1 hydrogen. We have no hydrogen over here. Okay, so that means, let's see, hydrogen. Oh, we forgot our hydrogen, didn't we? Let's say plus hydrogen. My bad. All right, so plus hydrogen. So we have hydrogen is a diatomic element. There you go. Sorry. So barium chloride plus hydrogen. I forgot about the hydrogen. And that's because I didn't do the steps that I always tell you guys to do because I was being lazy. Sorry. Okay, so we have 1 and 2, so we need to add a 2. So we have 2, 2, 2, 2, 1, 1. So we're good. So we only needed to add that. All right, so the question says how many, actually let's do our known. I like to do the known first for some reason and unknown. So the known is 1.25 times 10 to the 23rd molecules of HCl. Okay. Unknown is how many grams of barium chloride. So how many grams of barium chloride? Okay. So that's our known and unknown. So we always start with our known, right? So neither of these are moles, okay? So that means we must convert to moles, do a mole to mole ratio, then convert out of moles, okay? So we have a known, okay? 1.25 times 10 to the 23rd. That's our known. All right. So we need to get rid of this, okay, and convert to moles. So that means this is molecules. So that's when we use Avogadro's number. Molecules, HCl, for every 1 mole HCl. Okay, so we are now into moles, and now we can do our mole to mole ratio. So we've canceled our molecules. We need to do a mole to mole ratio. So mole of HCl compared to moles of, so we're looking at HCl and barium chloride. So we're looking at this one and this one. We don't care about the other two. Okay, so BaCl2. So there's 1 mole of BaCl2. We got that from here. And there are 2 moles of hydrochloric acid. Okay, so this is the mole to mole ratio. Then we need to convert to, looks like, grams of barium chloride. So 1 mole of barium chloride will have a certain mass, so grams of barium chloride. So we need to find out how much barium chloride weighs. I'm just going to do it on my calculator so that I don't run out of room. So barium weighs 137.33, 137.33, and we only have 1 of them. Okay, we have 1 of them, and then there's 2 chlorines. So I just do plus, open parentheses. Chlorine is here, so 35.453, 35.453 times 2. Close parentheses equal, so 208.236. Okay, so that's our equation. This is how you would set it up, okay? It's pretty long. But that's okay. The calculation's pretty easy. Okay, so we have this number, okay? So in the calculator, we are going to write, I like to do parentheses when I have these bigger calculations, 1.25 times 10. I just realized I've never used this calculator before. Hold on, give me a second. Let's see if that works out. Divided by, actually, I'm dumb. These will cancel out, so I don't even have to. So 1.25 divided by 6.02. We don't have to do times 1. Divided by 2 times 208.236 equals. So 21.619. 21.619. So let's look at, what's it called? Significant figures. We have 1, 2, 3. So that means we have 1, 2, 3, and we got to cut it off here. So 1 will not increase it. We don't look at this, okay? 1 will not increase it. So the actual final answer is 21.6 grams of barium chloride. That's our answer.